Now, let's come to this part where we describe dozen. Okay, so the title is Chemistry Dozen. In our study of chemistry, we would come across a system of calculation. But before we begin, we want to look at a few common sense in our lives. So one dozen of flowers, you have 12 flowers, right? So 2 dozen of flowers, you have 2 dozen. 2 times 12, you have 24. If you have 4.5 dozen, that will have 4.5 times 12, and that will give you 54. Okay, so now I want you to pay attention to this figure. Looking at this, if you buy 4.5 dozen of flower, are you getting 54 or you get 12? I'm sure your answer will be you're getting 54. So this 54 is what we call the actual amount that you get. Actual amount that you buy. Okay, actual amount. So I put a big N. This one is the standard number. Okay, I'll just call it a standard number because we all know that 1 dozen will have 12 units. Alright, so this is a standard number. We don't buy 12, it's just a standard number. And this is how much quantity you want. Okay, it depends on how many dozens you want. So this quantity, I'll just put small n, and here I'll put NA because now we are going to relate this with chemistry dozen. Alright, so now you look at this. You look at what I circle. Small n times big NA equals to big N. Okay, it is because of the quantity of chemistry dozen that you want to get, you times 12. But in chemistry, of course, the number is not 12 because they have set it as 1 mole will have 6.02 times 10 to the power 23 entities. Okay, let's just call them atoms first. Alright, so 2 mole will have 2 times 6.02 times 10 to the power 23 atoms. So would you get 1.204 times 10 to the power 24 atoms? Okay, let's try this as well. 4.5 times 6.02 times 10 to the power 23 atoms. So therefore you will get a figure, and this figure is, let's try 4.5 times 6.02. 4.5 times 6.02. So the number is 27.09. So it is 2.71 times 10 to the power 24 atoms. Okay, so now let's label them. This is what we call the chemistry dozen, the quantity that you want. Okay, so we call it mole, number of mole. Alright, so then you multiply by the standard Avogadro's number. Okay, it's just that 1 dozen will have 12, so the standard Avogadro's number is 1 mole will have 6.02 times 10 to the power 23. And then you have the number of atoms itself, the actual amount that you get. So this is actual and this is standard. So we can finalize our formula. Okay, in our future dealings, when we have this actual amount, when we are looking for the actual amount, we can use number of mole times Avogadro's constant. Okay, example, maybe this will be a good example. Let's try this. There is 0.38 mole of sodium atom in the container. Calculate the total number of sodium atoms in the container. Total number of sodium atoms. You see, 0.38 is like 0.38 dozen. Okay, So in this case, mole is 0.38, and they want the total number of sodium atoms. So you can put this total number of sodium atoms. That will give you 0.38 times 6.02 times 10 power 23. Alright, so you should be able to get a value of 2.29 times 10 power 23 sodium atom. You can draw a graphic like this to help to aid you in your study. Alright.